All right, let's try a couple more examples here and see where we go with this. So example 1b, I'm going to go from 1 to infinity of -1 to the k to the k over k factorial. Now here's the thing. There are two defining characteristics here that tell me ratio test. If you have k to the k, that's a tip-off for a ratio test. All right? If you have the base and the exponent both variable, that's one scenario. Also, I'm looking at this, and you have a factorial, that's your other tip-off that you're going to do a ratio test. All right? So two things are screaming the defining characteristics. You know, we like to talk about that. The defining characteristics here, the two things that are screaming out at us are the k to the k and the factorial. So with that ratio test, let's do it right now. The limit as k approaches infinity of the absolute value, -1 to the k plus 1, k plus 1 to the k plus 1, because you're going to take the next. Every single k you see goes to the next one, right? Over this k plus 1 factorial times the reciprocal, right? You're flipping it, multiplied by that reciprocal, k factorial over -1 to the k and k to the k. All right. Now let's take what we have here and split it up a little bit. I'm going to scoot this up a tad. Take what we have here, split it up so we can go through and we can simplify this. So I now have my limit as k approaches infinity of, now this -1, this is going to be absolute value out. This -1 is going to absolute value out, right? Because we're taking the absolute value, so the absolute value of a negative is just that positive. I'm okay with you just taking those out. You don't really have to simplify those. The absolute values take care of those more than anything. Okay. But this numerator up here can be broken to be k plus 1 to the k times k plus 1, right? Because I have these like bases. We would add the exponents because that's like to the first power. So like bases, you add those exponents over, if I break down this factorial, I have k plus 1 times k factorial times k factorial over k to the k. Let's simplify out a little bit more here. This k plus 1 takes out that k plus 1 as we simplify. So now I have the limit as k approaches infinity of k plus 1 to the k over k to the k. Do you see this? Now, both the numerator and the denominator are to the same exponent. So you could put that all into the same set of parentheses. So I have k plus 1 over k to the k, right? It's a what do you see in patterns here? I'm hoping that at least some of you are looking at that going, ooh, 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 right? What are you ooh, 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 oohing? It's E, right? It's E. Do you see that? That monomial k in the denominator split that up. Sorry, all this talking, I have to get some hot tea here. So I have the limit as k approaches infinity of 1 plus 1 over k to the k, which we know to be e. And it's just e to the first power because this is just a 1, right? Okay, now what is the value of e? Do you remember that? E to the first power? 2.718, blah, blah. Pardon me, blah, blah, blah from there. All right. So if I know this is now that value, that is greater than 1. What did we say when your R value, whoops, I should be writing out my R and I haven't been, doggone it. So this is my R is equivalent to this, right? So R actually equals E. So R equals E, which is greater than 1. And then what are my rules on the ratio test? What's it say? If R is greater than 1, then my series diverges. Oops. Therefore, the series diverges by that ratio test. Good. Good. The biggest deal on these, where I see people struggle with this a little bit, is just the algebra, right? It's just that algebra, just setting up that algebra that goes with this in order to pull this off. Good, good, good. Questions on that? Okay. All right. Well, you can't ask me questions right now. Make a note and then talk to me about it when we have our virtual sessions, or send me an email. This is okay, but this is not ideal for anyone. You should know that. This virtual just is what it is, and we're making it happen, and that's okay, right? Because we're all doing this, and we're doing what we got to do. That's okay. But we're doing it, guys. We're doing it. Okay, let's try one more here. We have example 1C. I'm taking this from 1 to infinity of -1 to the k plus 1 of e to the negative k and k squared plus 4. All right. I'm pausing because I'm tempted to use... No, I have to because that k squared plus 4. Okay, I was tempted to use the root test, but we'll go ahead with our ratio test here. Now, this one does not have any factorials. It doesn't have a k to a k, any of that, right? So you have to use the ratio test if those two criteria are in place. If those criteria are not in place, then you look back, take a step back and look and say, ooh, what can I do? We know with this negative sign right here, then we're going to have to do something, right? Honestly, y'all, if I were doing this, I would absolute value this. And then... No, we kind of need to do the ratio test. I was thinking, how could we do a comparison on this or any of that? No, none of that's going to work as well because I have this E down here. So our ratio test is going to be our best bet, right? Okay, so let's do it. See, it's good to think about that stuff. You think through the process and, oh, what could be a good way or a better way? That's always a good thing. So if I have this K here, whenever I'm looking at this, then I'm going to send that through. -1 to the k plus 2 is what it would be, because you put a k plus 1 in for the k that I'm looking at. And then I'm going to send it like this. I'm going to put that e to the negative k down below. So I'm going to have -1 to the k plus 1, k squared plus 4 over e to the k. It's not negative anymore because I'm moving it down below, because I don't like to deal with that negative exponent. So now I have k plus 1 squared plus 4 over e to the k plus 1 times e to the k over -1 to the k plus 1 and then k squared plus 4. That's absolute value. So we know right off the bat, those go right off, right? And then I have, no, I'm not going to, maybe if we were sitting in class, I'd shortcut this a little bit more, but I'm not going to while we're trying to do it like this. I have the k plus 1 squared here. I'm going to go ahead and FOIL that out to get k squared plus 2k plus 1 plus 4, which would really be plus 5, over e to the k times e to the k over k squared plus 4. Right? So now I have e to the k. Those cancel. I'm going to combine that 1 plus 4. So I really have now the limit as k approaches infinity here of k squared plus 2k plus 5 over e k squared plus 4e. I'm taking my limit as k approaches infinity. My leading coefficients here are the same, k squared over k squared. So this will be 1 over e. And we know that 1 over e is less than 1. Therefore, converges. Therefore, we can write our, that's along the series, converges absolutely by the ratio test. Good. All right. So it doesn't always have to have that factorial and have to have that k to the k in order to use the ratio test.